So, kinematic graphs. Okay? So every single thing we're going to do for the next 2 days has to do with graphs. Okay. So, concept and definition. So in math and science, if two quantities are somehow related together, well, doesn't have to be just two. You could relate what? Three, four, five. You could relate 100 quantities if you want. But the graph gets more complicated and what they call more multi-dimensional. Okay? No, we're only going to relate how many things? Just two. So that makes the graph how many dimensional? Two-dimensional. You have an x-axis and you have a y-axis. Done. That's it. Okay? The relation can be described using one or more, depends, of the following methods. You can describe them numerically. Okay, I think is this take? Yeah. So go ahead. So numerically, what does a numerical relation mean? A numerical relation means make a table of two columns, or could be two rows. Although I've seen more columns than rows. Two columns and list the corresponding values of both quantities. How many people have seen this done before? How many people have done a table of values, or they call it a T chart because the x's are here and the perfect. That's exactly it. If you're lucky enough to have measured numbers, great. You can make what? You can make a table of values and see how things relate if they do at any in any way. Okay, so that's one way. Another way is mathematical. This is always the what the most like the most unguaranteed one. Okay, you can never guarantee that you're gonna be able to find a what. In fact, the whole point of science and math is to find the equation that what that describes something. For example, let's say that we do an experiment and we measure a certain input versus a certain what? What's the opposite of input? Output. The whole point is to try to what? To find the equation that relates the input to the output. Sometimes the equation is easy to what? To predict. Oftentimes it's very, very, very difficult. So what do we just have? We just have. I'll give you an example. Pediatricians. What's a pediatrician? A kid doctor. Exactly. So what do they study? For example, they always have what they want to relate the what the height of the child to the what to the age. Okay. Do you think there's a perfect equation that measures that? No. But are there charts that tell you how tall a kid should be depending on the age? Absolutely. So instead of having a perfect equation, because it has so many factors in it, we just depend on what? A numerical chart, for example. Okay? Like my dad is a pediatrician, and he's always looking at charts to what to see, okay, below average, at average, above average, and so on and so forth. Okay? So the second one is mathematical, which is always harder to come by. Third one, verbal. You can describe it in words. You can say, for example, that for every single extra hour that you study, your mark should go up by 0.5%. That is a verbal description of what? Of a relation between hours you study, which is your input. You always have to have an input, which is the output depends on it, is what is how much your mark is in this course. So it describes with words how one quantity would change if the other changed. The last one is what's interesting to us for the next couple of days. Graphical. Sketch a graph, like you've done so much in grade 9 and 10, and maybe 11 as well right now. Sketch a graph that shows with lines or curves, okay, how one quantity responds to the other, if it even responds. By the way, the good news about grade 11 is that I will not give you any graph with curves. I will only graphs with what? With straight lines. Why? Couple of things. Number one, obviously, there's a much easier geometry to straight lines than with curves. Also, with curves. By the way, what is the easiest curve? Like, what's the function that is basically the next one that's more complex after a straight line? So basically, what's the name of that function? So the shape is called what? Starts with P, parabola, but the function itself is called what? Q, quadratic, exactly. Even a quadratic is very hard to what? It's very hard to find the shape of, for example, because you have to what? You have to what? Trace the curve, and the curve will introduce a lot of decimals to it, right? So that's why I'm going to keep it easy on you and do what? And do line. How about grade 12? Still more lines. By the way, kinematic graphs is not a part of the curriculum in grade 12. By the way, grade 11 and 12, they do share a lot of topics. I would say, about 80%. But there are topics that are covered in grade 11, not covered in grade 12. Guess what? And then they cover them again in what? First year university physics. Okay, like the topic of circuits. For some reason, circuits 15 years ago used to be circuits, like building circuits, used to be a part of grade 12, not grade 11. They pushed it to grade 11, and they were like, nope, don't cover it in grade 12. They'll cover it in first year, which gives you a gap, which is weird, but it is what it is. Kinematic graphs is not part of grade 12 curriculum. So we will not even see this in grade 12. Okay? So let's actually talk about what? Kinematic graphs for the rest of today and tomorrow as well. Okay? Oh, sorry. So the second reason of why I cannot teach you analysis of curves is because we need calculus for it. By the way, calculus was invented to analyze anything that does not follow what? A straight line. Any straight line analysis is straightforward since the day of the Greeks and the Babylonians and the Chinese is fully understood. Once you curve it, that's it. Calculus is needed. Why? Because of these small changes over a very small interval. Okay, let's go to the next slide, everyone. So, graphical is the thing we need. Okay, so how many types of kinematic graphs can only exist? 3. Here's the good news, everyone. Listen up. We're not going to cover all 3. We're only going to focus on the first 2. We're only going to focus on the first 2. So what's the first one? The first one is called position versus time. By the way, get used to the word versus. They always say y versus x. It just means y and x. So position versus time. Or it means what? How does position change? If it does, by the way, just so you know, everyone, a graph does not mean that something has to change according to something else. It just means that if one thing is changing, the other one could change or could not respond. Okay? So position versus time tells us how the position of an object changes, if it does, as time passes. What's the symbol for that graph? Well, what's the symbol for position? D with a what? Yeah, well, with Microsoft PowerPoint, I can't put an arrow. So if you write it, please make sure you put an arrow on top of that lowercase d. It's already written for you. Just make sure you put an arrow on top of the d, please. I cannot hack it with the Microsoft PowerPoint. Okay, so that is our first what? Type or kind of what? Of a graph. What's the second one? Absolutely. Velocity as time passes by. That tells you exactly in the same spirit how the velocity or speed, if you're keeping the same direction, but please always think of it always as legit velocity. Velocity of an object changes if it does as time passes. What is the quick name of that? Vt. Some people say v slash t. Some people say v dash t. I like the dash. Okay, so v with an arrow on top of the v, dash t. Okay, vt graph. What's the last one? Acceleration versus time. Tells us how the acceleration of an object changes as time passes by. And finally, this has the symbol a dash t. This is the only one we're not going to cover. We're going to cover position versus time. We're going to cover velocity versus time. But we are not going to cover acceleration versus time. Okay? Couple of reasons. Number one, to really cover acceleration versus time, especially in interesting cases, calculus is needed. I know, honestly, and that's one of the reasons to always tell you that at the end of the day, math and physics are really just what? Just the same thing. By the way, people ask me, which one do you like teaching more, calculus or physics? I'm like, to me, after 25 years of studying them, they're really just what? Identical twins. They're two sides of the same coin, okay? But that's one reason. By the way, there's another reason. We're going to act out some of those motions. It's going to be very hard to act out what? Acceleration versus time. I'll show you why, okay? All right, everyone, let's start with the first one. So we said that our graphs are going to be how many dimensional? 2-dimensional only. So two things relate together. So any position time graph, everyone, potentially looks like this. So here's my question. Which one should be this way and which one should be this way? Ask yourself this question. Which one has to change first and which one has to respond? What always changes without you controlling it ever? Time. So is time the dependent variable or the independent variable? There you go. So that means what? You always put the what? You always put the independent variable, right? That's what we do in grade 9 and 10 and 11. You put the independent variable always here. And what do you put there? The dependent variable, exactly. So technically, this usually is given what name or what symbol? No, time. Sorry, what symbol? X. However, now we are having what? Our input as a very specific what? Quantity, which is time. So this has to take small t, and this has to take what? Position is what? D with an arrow. Okay. So now, what kind of units could we use here? whatever you want. By the way, just so you know, in this unit, not everything has to be in seconds and meters. You still can have other units. I'm just saying if you want to standardize, then you have to go with seconds and meters. Okay? So yes. So I will give you We'll do a lot of examples today and tomorrow, using seconds, using minutes, using hours, using whatever you want. As far as this is concerned, again, this has to have an arrow on top. This needs a what? Also, first of all, a unit. Meters, kilometers, feet, light years, whatever. But it also needs a what? Vector. Needs that. Thank you. Obviously, your directions could be anything else. Could be, as someone said yesterday, north 30 degrees east, for example. Fine. But you know what? Let's keep it simple for today. Let's just say our directions are going to be north, south, east, west, forward, backward, that kind of stuff. Okay? Now, what can you sketch inside? How do graphs look like? Show me with your finger a graph. By the way, a graph, yeah. Sure. Also, it could look like a what? Like a weird curve. So this could be what? Everyone, go ahead. This could be the what? The position, time, behavior of some object called object number 1. What's another way you could show a graph? You could do this. That's an example of something I'm not going to give you, because this is a what? This is a curve. Curve, not curved line. Oh, did you say curved line? Oh, no, no. You said curved line. You can just say curve. Because technically it's a paradox to say like a curved line. Just say curve. Make sense? Okay, that's all. Because a line is not a curve and vice versa. Question for you. How else could I actually do another object? Go what? Go down and even what? Cross the what? So go what? Which means what? Sign-wise goes what? Negative. I'm not going to give you what? I'm not going to give you any object that dips what? Below. All the objects I'm going to give you are always going to stay where? Above. They're going to stay with a positive position. Okay? I mean, by the way, I will explain to you what it means, but I'm not going to give it to you as an assessment. I will still mention. Yes. It could be. Okay. Is this a perfect wave? See, that's the thing. Waves, we're going to study waves for a whole unit. Waves have to perfectly repeat themselves, like a perfect sine or a cosine wave. This doesn't, so I can't call it a wave. Okay? I'm crossing this one out because I'm not going to give you examples on it. Okay? All right. So the first thing I want to do with you is this. Everyone, let's do an example. Do you have this already sketched for you? Perfect. Okay. What do I want you to say? Okay, everyone, pencils down. I am always amazed, let's say, at people who, even grade 11 sometimes, are not sure exactly how to read or interpret graphs. So let's think about this for a second. What does this graph first represent? By the way, it's important to always know. By the way, is this ever going to change? No, this always got to stay time. Could this one change? Yeah, because we said we have how many kinds of graphs? 3. You can either describe position versus time, or velocity over time, or so it's important to know which graph is describing which. This is a what graph? Position. Okay, everyone, let's think about this. What is the value? What's the value right here, time-wise? So I want you to write 0 here. Like make a small dash. Actually, I can do it on the thing. Yeah, I should start adding it to my PowerPoint. So everyone, just to emphasize that this is a 0, go ahead and just put 0. Also, what is this point as far as this is concerned? Go ahead. 0. No, like the base of that axis, also 0. What do you call the 0, 0? The what? The origin. Thank you. Okay. So everyone, I want you to tell me how to act out this motion. I want you, I'm the puppet, and you're moving me. Yeah. Tell me how to, raise your hand. Tell me how to act out the motion from very beginning to very end. I'll give you an easy way to start. At 0 time, like at the beginning of the stopwatch, Where am I located? No, I'm not at the origin. Does this graph go through the origin? It doesn't. If it did, then you have to tell me what? Start where? At the origin. Apparently, at 0 time, I am not cutting through the origin. Where am I placed at 0 time, Muhammad? 10 feet which way? Thank you, because you have to tell me. Okay, we have to choose an origin, everyone. Let's say that the origin is right here in front of the socket. Okay, all right. Where is west and east to you? To you. You're facing north this way, so that's what? East, and that's west. Okay. So the moment we start this experiment, where am I located? Here? No. 10 feet which way? West. So when you open your eyes, I have got to be right here. Make sense? Okay. Let's start. The easiest way to start this is to see. Okay. So at 0, where was I? At what? 10. Okay. Let's look at this. Let's see. What happened to my position? Did it start going down or going up? So did I start going more east or more west? Okay, hold on. Ask yourself this question. After 5 minutes, where was I located? No, 20. Actually, it's not exactly 20. It's somewhere in here, but who cares? After 10 minutes, where was I? 40. So where am I moving? More east or more west? Do you see what I mean? So I'm okay. At 0, where was I? 10 feet west. How about after 10 minutes? I was located at 40 feet where? So that side or that side? West is, but that's east. And that everyone, hold on. And that's why I do graphs with you. This tells you nothing about the physical motion of the object. This just tells you about the what? The value of its position in time. No, everyone, did you see what just happened? You and others who did not say it. I know a few others still think the same way. You think that the way that the graph looks like is physically the what? The motion of the object in real space. It has nothing to do with real space. Heck, why didn't you tell me that the object is moving tilted at like 30 degrees? Do you see what I mean? This has nothing to do. Okay, one way to say it is that this is not you looking down and seeing a what? A motion on a map. Do you see what I mean? This is only telling you as time goes by, what value do you have for the what? For the position, not which way you're moving. You could tell which way you're moving, but once you know how your values change. Do you see what I mean now? This is not a physical picture. It's a what? It's a graph, which tells you what? Something changes, another thing responds. So let's start again. 10 feet. After 10 minutes, where was I located? 40 feet which way? So somehow I have to make my way over 10 minutes. Where? To that point. Keep going. After 15 minutes, where was I? Or where would I be? Okay. So obviously you're going to tell me, Mr. Ramadan, start moving which way? And I have to keep moving west for how many minutes? No, uh, no. Hold on, relax. Do it segment by segment. From 0 to 15, I made my way from what? 10 feet west to 60 feet west. Okay, so that means what? Over 50 minutes, I have to go how much of a displacement? No, no, 50. Remember, my positions were 10 and 60. So my displacement between them was how big? Do you see now the difference between position and displacement? Position, you need how many values? Displacement covers in between. Okay? Thank you. Okay, so how long am I going to do this for? 15 minutes. Okay, everyone, eyes on me. Okay, I got to 60. Okay, what does that small line mean? How come I don't keep moving? Thank you. My position is neither what? Increasing nor. So what does this mean, everyone? For 5 minutes, my position was what? Locked at how much? At 60 feet right there. So I walk for 15 minutes. And once I reach what you tell me? Stop. And hold it for how long? Okay. Now, what do I do from 20 minutes to 25 minutes? How come I'm not moving forward? What? Okay. Perfect. Am I physically going down or does the graph go down? What does the graph go down mean? My values are what? Decreasing. So now, am I going to go further west or technically I'm going to be displaced east? Yeah, because I'm losing west. Okay, over 5 minutes. I need to make it from 60 to what? Apparently, I need to get back to the position marker. What? 30. Over how much time? Yeah. No. 5 minutes. That means what? Quite a huge speed, right? I have to go. Well, it's not a speed compared to before. Okay. 30 what? 30 feet from the what? From the origin. Not from my original point, from the origin itself. Okay. What do I do? And again, I stop for how long? For another 5 minutes. At what spot? At the 30 marker spot. And then what do I do over 10 minutes? From 30 to 40? I go back where? To my original or to the actual origin? To the actual origin. Over how long? Over 10 minutes. And that's it. Do you see now how we read graphs? They don't tell you the actual picture. They tell you how the things are what? Going up or what? No, no, or stay still, locked at a certain value. Perfect. Awesome. So let's actually write the description here. That's what the next slide is for. Come on. Okay. So don't write this one. So let's describe the motion of such an object. First, where was I located? Go ahead. So the object was 10 feet, 10 feet west of the actual origin when we started observing it at t equals 0. Okay, so that is the initial positioning of the whole thing. This is t equals 0. This is the beginning of the experiment. Sorry? Yeah, this is what those lines are for. Yes. Okay. All right. Then what happened next? It started moving west more and more until it got to a position, or it got to 60 feet west. See, it did not move 60 feet west. It got to 60 feet west. How much did it move actually? 50 feet west. Exactly. It did not move 60. It moved, you see, one word makes a difference. It did not move 60. It moved to 60. Makes a whole difference to use the word to or not. Whenever you use from to, you're talking about position. So it started moving west more and more until it got to 60 feet west after 15 minutes of continuous pace motion. All right. Then you told me to stop. Stopping means what? My graph has a vertical position line. I am locking in my position. I'm not moving. So that means I kept for 5 minutes a value of 60. It stood still, kept the same position or location for 5 solid minutes. Then you still moved, but now your position is getting less west, which means you're getting, what does less west mean? More east, exactly. It's starting moving less west, which means retreat. When you retreat, you go back. Retreating more east until it was at 30 feet, which means at a position number line, at a number line position, at 30 feet west after 5 more minutes. And then you told me, stay still at 30 for 5 more minutes. And then you told me to keep going more east, less west, same meaning. But this time over 10 minutes until you get back not to your original location, no, but the actual origin of your universe, which is the perfect 0 point. The whole thing took 40 minutes. Here's my question to you, everyone, as you keep copying. Oh my God, sorry. Let me just check if it's still recording. Sorry. I just need to check if it's still recording. I hope it is. Oh. Yes, it is. Good. My bad. 1 second. All right. My question to you is, everyone, what would it have meant if this line kept going? What does negative mean? Exactly, because then I would have made it to the actual origin and then keep going what? East. East of the origin, which means what? Yes, if my direction is west and it flips negative, what's negative west? Positive east, and I'm actually on the eastern side of what? Of the universe right now. Perfect. But I will never show you something that dips below, because you know what? I think that's more than enough analysis for the whole thing. Okay, the whole thing took 40 minutes. Also, you did not cross to the east one, even though you were displaced what? You see the difference? You do not have to be, remember that example? You do not have to be on the eastern side. You do not have to be on the eastern side of the universe to move east. You could just move east and still end up purely on the western side. Okay? All right. Yeah. I'm not going to even ask for a show of hands, but at least Yasmin, she admitted she's been reading graphs wrong the whole life, because you've never been told the graph as a what? As a story. Yeah, exactly. You thought that the graph tells you physically how something is moving. No, it's how a certain value is increasing or decreasing or not changing as time or as some kind of independent. Again, that's how I've been teaching for the last 25 years. Tell everything as a story. Everyone gets it. Yep, of course. Yeah. And again, don't we remember our bedtime childhood stories? I do, because they were stories. You lived it. You saw it. Okay? All right. What is the easiest thing you can do with a straight line in grade 9 and 10? What does every straight line have? Actually, what does every curve have, but definitely straight lines for sure. What can you calculate using a straight line? If you have the equation of a straight line, or if someone gives you 2 points, what can you calculate between them? The slope of what? Of a straight line. Let's calculate. By the way, technically, how many different straight lines do you have here? How many different segments do we have? We have 5. We have segment 1, segment 2, segment 3, segment 4, segment 5. So let's actually what? Let's actually calculate the slope of what? Of each segment right here. Okay? So everyone, let me just go to the next slide. By the way, I already have this already filled out, so I'm going to upload it right at lunch. Okay? All right. So let's go. Can someone tell me what's the equation for slope? People are still saying y equals mx plus b. People, y equal mx plus b is not the equation for slope. It's the equation for a straight line. Do you see the difference? A slope is a what? Is a part of a what? Is a part of a straight line. What's the equation for the m part? For the m part. Say again. Y2 minus over x2 minus. So final minus initial over final minus initial. So we know. How many people agree with this? Is that what slope is? Yeah. By the way, this is not grade 11. This is, I don't care if you do a PhD in math. This is what slope is. However, we don't have y's and x's. My x's now are called what? T. And my y's are called what? Position. Remember, not everything is x and y. X and y are just placeholder. You have to be natural. You have to be exactly what the system describes, time and position. So let's change it. Ta-da! Again, I can't have an arrow, so please make sure you have an arrow here. Okay, everyone, let's look at the first segment. Can someone tell me what is the initial time at which the first segment started? Like that. So the first segment started at how many seconds? 0 seconds. And that's why I'm giving you those dashed lines to make it easier for you to see the interest points. The first segment ended where? Ended at what time? So it went from what to what? From 0 to 15. How about position marker-wise? It went from, again, I need the full position. 10 feet, actually. 10 feet west to 60 feet west. Perfect. Do you see good teaching? Do you see how you end up really? I didn't say it. You said. You discovered it. And that's why you will never forget it. Boom. However, listen, no, hold on. I still have to be real here. You said it's displacement. It sure is. But you forgot it's still being divided by what? Can you tell me what do we measure using feet per minute or meters per second or kilometers per hour? Not speed, because it has a direction. Thank you. The velocity of what? Of a position time graph. Sorry, the slope of a position time graph gives you what? Gives you velocity. Yes, because it tells you how fast you were going straight from beginning to end. Mm-hmm. Yes. Oh, okay, hold on. That was, and indeed what, to Yasmin's point, that was an indeed what physical portrayal of what really happened. That was not a graph. That was a grid. Okay, good. I just want to make sure. The hypotenuse, yes. Exactly. Remember Jack and Jill? Jack and Jill, I did not watch them. I just what? Assumed they beelined it from beginning to end. That would be my velocity. Yeah, exactly. Speed is if I keep what? Thank you. So 60 feet west minus 10 feet west, blah, blah, blah. 33. Obviously, it's a decimal. So yes. Okay. Can someone tell me, am I going to calculate the slope for the second segment kind of the same way? Here's my question. How big time-wise was the second segment? 5 minutes. However, what position did it start from and what position did it end at? What position did the second segment start at? 60. And it ended at? What's 60 minus 60? 0. What does 0 speed mean? You what? You didn't move, which is exactly in line with what? With how I acted it out. You told me to stop, and I did come to a stop. Okay? Obviously, everyone, whenever you divide 0 by anything, what do you get? Think about it. We divide 0 by anything. What do you get? Oh, no, okay. Think money. You have $0 and you want to give it to 4 people. Practically, how much does each person get? 0. You're thinking of 5 divided by 0, my friend. Can you ever divide by a 0? Can you divide 0 by anything? No, hold on. Can you divide 0 by anything? Yes. Can you divide anything by 0? Big, big, big no. By the way, what do you always get when you divide anything by 0? What? No. When you divide something by 0, you get, actually, not syntax. Not syntax. By the way, interesting. Because so many of you are going to go to engineering or science something, and you're going to have to take a what? A what? Computing or coding course. Syntax error means what? You wrote a bad line, like there's a comma missing or a bracket missing or something. That's not syntax. That's actually called what? input error or math. How many people got math error when you sometimes plug things in into your calculator? You do it. You know why? Okay, what's everyone? Aside from dividing by zero, which is a big blasphemy in math, what other bad things you cannot do in math? No, no, nope. That will give you what? Missing bracket. I'm talking about math error. What can you never do in a calculator? Question: what's the square root of 9? No tricks. What's the square root of 9? Uh, by the way, I am not harping on you here. You go to Western right now and you stop people in first year engineering and tell them what's the square root of 9, and they will tell you 3. You're like, no. Give them the the Obama not impressed face. No, no, and they were like, yes, it's 3. You're like, no, it's not 3. They will pull up their cell phone or calculator. It's like square root of 9, 3. And I'm like, I don't care. That's not true. Plus or minus. You are forgetting the minus. We always forget the minus. Even though sometimes, which one do we need? No, no. We need the what? Half the time sometimes in our math and physics solutions, the correct answer is the what? Is the minus. But yet we never what? We never remember it because we always go what? 3, right? Because 3 squared is what? What's also negative 3 squared when you multiply a negative by a negative? What do you still get? But no one remembers the negative. And by the way, you don't, again, you thought you understood quadratics? Solve this. Why does it not make sense to say just plus 3? How many times does it cut? Twice. How many x-intercepts do you have? Thank you. The fact that you said this means you're saying this one does not exist. Really? Do you see how everything relates together? The fact that you think that the square root of 9 is only 3 means you do not recognize quadratics. Well, guess what? Quadratics don't need you because they already exist. Do you see what I mean now? You have got to remember the minus 3. Here's my question. What's the square root of minus 9? Charges? But why can't I get the square root of minus 9? Why does it not exist? Thank you. How can you create a 9 from multiplying what together? 2 3s or 2 what? Negative 3s. Can you ever multiply 2 identical numbers and produce a negative? No, because if you multiply 2 positives, what do you still get? If you multiply 2 negatives, what do you still get? There is no way to multiply identical entities and get what? Negative. Do you see why now? That's a math error. Do you see what I mean now? So math error is not the same as syntax error. Syntax error means you coded wrong. Math error means you gave me something that makes no sense. Okay? You can't. Yes, it's called complex numbers, and it's a whole different field of math. They only cover it in first year. Okay? All right. How about the third, everyone? How many people got the third stage? Did anyone bother to do the third stage? Okay, I'll ask you a question. How long in time was the third segment? How long in time was the third segment? How many? 5? Was it 5? Okay. But what position did you start from? 60. What position did you go to? Okay. Hold on. But wait a minute. Is it 60 minus 30 or 30 minus 60 though? Remember, it's final minus initial for that segment. 30 minus 60. What's 30 minus 60? Negative 30. But it's going to be negative 30 west, which is going to be what? 30 meters. And you did tell me to go which way? Do you see now how everything connects? Ta-da. 30 minus 60 minus 30. What should I do with that? Come on. What should I do with this? By the way, you know what? Let's answer the question that you did not stop asking me yesterday. Is it bad? Is it unallowed to get a negative vector? No, unallowed mathematically. Yeah, guess what? Math said it, it's correct. However, what would be a better look for this? Thank you, because it will give you a physical sense of which, if you told me right now, Mr. Ramadan, I want you to go negative 6 meters west. Why? Just tell me what? 6 meters? Thank you. There we go. My velocity was 6 feet per minute in the east direction for only that segment, no more, and not before, not after. What was my fourth segment again? You told me to stop. So what should it be? What should my speed or velocity be when I stay still? 0, because I was at 30 and I kept it 30, I think, for 5 minutes, I think. Yes, I did. I got to 30 DI and I kept it to 30 DF. What was my last segment? Last segment. How long did it take? 10 minutes. And I started from when? Sorry, from what marker? From what spot? 30. And I made my way to what? No. The last segment. I started from 30 and I made my way to what? To 0. To 0 meters, sorry, to 0 feet west. Basically to the origin. Which again says what? I moved even more east, which is why I got a negative west. Nice. So all of those units are units of what? They are unit of distance divided by unit of time, which means it's a unit of what? Velocity or speed. Thank you. Because it has a direction, we have to say velocity. Awesome. You can never do physics without math, and you can never do math without really having a physics application to it. That's why I love teaching this course, because I end up doing both at the same time. Okay? All right. So now let's go to the what? Hmm? It's okay. All right. No fun. Sally, whenever you want to go. Yeah. Okay, let me just go to the next slide. Again, the whole thing is filled. So like on my hard drive or my USB. So I'll upload it right after lunch or right at lunch. Okay, but I just want to go to at least another graph today as well. Okay. So what do we conclude? What pearls of wisdom here? Velocity is the what? Is the slope of which graph though? Of a position time graph. Remember everyone, you do not get velocity unless you take the slope of a position time graph. Yes, because he's wise and he knows. I'm pretty sure he knows physics. Who? Come on, I didn't watch it and I still know who he is. Yeah, go ahead. See you. Yeah, do us proud, please. Okay, let's go to the next slide. Come on. Velocity time graph. Are we still going to approach it the same way? What do you think? Are we still going to approach it the same way? In a way, yes, a graph is a graph. It has very important differences, but the essence is still the same. So, what is the difference first when it comes to the axes? Which one does not change ever? Time. Time is always going, passing by. You cannot control it. It is the independent variable. How about your, yes, again, your V now has to have an arrow on top, please. It could be in meters per, by the way, you see how I'm screwing up with the units? I'm giving you units you've never seen before. Usually you do what? Meters per second and something per hour. No, this time I'm doing meters per hour and feet per second. It doesn't matter. Distance over time. That's all we care about. Okay? And directions are north, south, east, west. One second. Okay. Okay, so everyone, just listen carefully. I'm just going to say this once in this unit, but I'm going to say it again in the next unit. The only unit, listen up, the only unit the only unit of physics where your units of measurement do not need to be standardized into meters and seconds and kilograms is kinematic. You can just, by the way, do you always have to describe the speed of a car outside in meters per second? You could, but you don't have to. It's actually more physical to use what? Kilometers per hour. That's my point. When you start the unit of forces, when you do, everyone, when you do any physics, by the way, is kinematics really physics? It's not. It's math, right? Every single thing we've been doing is math. Math doesn't have units. Physics has what? Yes. When you start doing actual physics, like forces or energy or electricity and magnetism or circuits, then you have to use what? Meters, seconds, kilograms. Does anyone know how we measure voltage? Volts. Does anyone know how we measure current? How many people have heard of the ampere or the amp? How many people have heard of the ohm for measuring resistance? How many people have heard of, oh my God, hold on, Coulomb for measuring electric charge, like collected on a body, like when you walk and you collect charge and then you touch someone and zaps them? These are physics units. You have to use them in physics. Do you see what I mean? In this unit, everyone, just use the units that you like or the one I have in the what in the question. Okay. Can I sketch the same? Can I sketch the same kind of curves I sketched for the first one? Yeah, anything will do. So everyone, here it is. But I chose now a line going down. The same weird curve from before. And also what? An object that dips below the axis. Which one am I not going to give you? Anything that goes negative as a velocity. Which really just means what? It's positive when you what? Flip the velocity. But I'm not going to bother you with that. We've discussed flipping directions enough in this course so far. Good? Okay, let's do an example. I'm assuming you have this. Good. Yes. Hold on. Hold on. Okay. I like that you're seeing the idea. Okay. Tell me how to act it out now. I'm your puppet. Tell me what to do. Everyone, come on. Phones away. Let's focus. What does that tell you? Again, what do you put here? What do you put here? Okay. So let's start. At moment zero, at time zero, what was my velocity? So what does that mean? When you opened your eyes, was I already in motion or was I still? When you opened your eyes at stopwatch time zero, I was there. Okay, let's read it segment by segment. Segment one goes from when to when? Segment one goes from when to when? From 0 minutes to no to 6 minutes. It took the first segment took 6 minutes. What was my speed at the beginning of it? And what was my speed at the end of it? So I had to start from what? What's the word? From rest. Remember, from rest means what? Initial zero speed. And I had to build up my position or my speed. My speed to what speed? After 6 minutes, you had to see me going at what velocity? 8, going, physically going south. So we have to agree. Okay, you know what? Everyone, I'm going to say this is south. I'm going to say this is south. Okay, so you open your eyes. What am I doing? I'm not moving. And then you tell me, Mr. Ramadan, you have how much time? You've got 6 minutes to build up to what speed? 8 meters per minute. Come on. Is 8 meters per minute really that fast? If you give me a minute right now, a minute, you don't think that I can go 8 meters? By the way, how long is 8 meters? The width of this classroom, not even. Do you think I can do this in a 6 minutes? That's my, sorry, in a minute? Yes. But my point is, I have to start from 0 speed to what speed? What do you call it when you increase your speed? Thank you. All right. So you tell me move, and I have to start at what speed? But then I have to start what? Increasing my what? My speed, my speed, my speed, my speed, my speed, until I'm done with how much time? After 6 minutes, I had to be going at what speed? 8 meters per minute. Okay. What's my second line? Second segment? How long? From no, no, from 9. Sorry, from 6 to 9. So how long in time? Come on, everyone, just focus on me. How long? What did I do over these 3 minutes? I came to a what? Did I? You see how? So you see what a vertical line means in one that it doesn't mean in the other? What does this vertical line mean? Did you come to a stop, or did your velocity increase come to a stop? Your velocity is increasing came to a what? When you stop increasing velocity, what do you? So what do you call it? Come on the highway. On the highway, I'm cruising. So that means what? I had to start from 0. I had to what? Speed up. Once I hit 8 meters per minute, what did I do? You told me, all right, hit the cruise. For how long? 3 minutes. Okay, I'm done with 3 minutes. What happens next? Also over 3 minutes. I have to do what to my speed? I have got, and I have to really, really yank it up. From what speed? From what speed? From 8 meters per minute to what? 20, triple the speed. I had to basically get to what could to triple my running speed. So that, but over how much time only? Oh, I have to do more in what? Exactly, more in less, which means my acceleration is what? Really, my acceleration is high. Thank you. Anyway, over 3 minutes, I'm gonna go from here to running. What do I do once I get to 24 meters per minute? What do I do? What do I do? Cruise. For how long? And then what do I do? Over 9 minutes, from 15 to 24. What do I do? Is my speed increasing now or decreasing in value? It's decreasing. From what to what? From 24 to 0. What does that mean? Over 9 minutes, I have to come to a what? Done. Do you see, everyone? Do you see how harder it is to act out velocity compared to position? Yeah, because why? When they depend on time more and more and more, it gets harder to what? To get the coordination done. That's why. All right, last thing, let's just describe this motion. Okay, the object was at rest. By the way, question for you. Did it matter where I started? Is there any position information in this graph? Whether I started from here, from there, from Mr. Smilovich's room, from the end of the hallway, does it matter? No. All it matters is I need enough space to what? To keep moving. Exactly. There is absolutely no point of knowing where I started or where I ended. I just needed to know how I moved. Perfect. So it was at rest when we started observing it at t equals 0. Okay. Yes, hello?
Hi, do you have Cora Ibden class?
She is here.
She's being signed out for an appointment.
Okay, good. Thank you so much.
Thanks.
Okay, just so lucky. All right. That's okay. I'm 41. I'm thick-skinned. Nothing gets to me. Um, nothing offends me anymore. Okay. Oh. It started moving south. Sorry. It started moving south. Does that mean it started moving to south as well? Yeah. I mean, I started moving in the south direction until it got to a speed. By the way, should I say speed or velocity? What do you think? Should I say it got to a velocity or it got to a speed? I do, but I've already said the what? Do you see what I mean? I already said the direction, so now I just want to give you the magnitude of the motion. So it's okay to say I moved south and I got to a speed. That means I am going at a velocity of 8 meters per minute south after 6 minutes. Then what did you tell me to do? Cruise control. Then it cruised, kept the same speed for 3 minutes. And then you told me, pump it up. You had to speed up from 8 to 24 in just 3 minutes. Imagine, I did in 3 minutes here much more than I did in 6 minutes here. In those 6 minutes, I only went from 0 to 8. In those 3 minutes, I went from 8 to 24. That's a lot of achievement in even much lesser time. In the next 3 minutes, it sped up all the way up to 24 meters per minute. By the way, still moving which direction? Still moving south. I mean, how can you reverse if you're speeding up? Okay, what did I do then? Cruise control again. I cruise controlled for another 3 minutes at 24. And then you told me, bring it down. Bring it down means your speed keeps decreasing until it got to a stop. V equals 0 within or over 9 minutes. The whole trip took how long? The whole thing. The whole thing took 24 minutes. Okay, which direction did I keep moving the whole time? Did I ever go north? Even though I what? Perfect, thank you. So everyone, slowing down does not mean what? Thank you. Slowing down does not mean physically what? Going what? Going backward. No, it means could it mean you're being pulled backward? Okay, slowing down. Does it mean physically going backward? But does it mean at least that someone is pulling you backward? There you go. By the way, this is important because when you talk about forces, we're going to talk about what? Acceleration, someone pushing you what? Deceleration, someone what? But you're still moving what? You're still moving forward. I'm just stealing from his motion. Perfect. Nice. Your t-shirt is good. The whole thing took 24 minutes. Also, the object was moving south the whole time. By the way, how about saying this? The object was on the south side of the universe the whole time. Does that make sense? I'll repeat it again. The object was on the south side. Everyone, imagine if this was north and this was south. Does this mean that the object was on the south side of the universe the whole time? Does moving to the south meaning that you are on the southern side of the universe? No, you could still be on the what? The north. You could still start from the north and end in the what? But my point is, do you even have any? Thank you. Are you in south position? Do you have to be in south position for this? No. You could still be way in the north, but you're displacing which way? Thank you. You got it. Yes. To move to the south, to move towards the south or the north, you do not have to be in that physical what region. You are just displacing yourself more closer to it.